Okay, this is the final exam review for physics, and I thought it'd be useful to post these reviews for many reasons, but one of which is I know it's getting late in the game and some students may be absent, and so the best way to review for the test is just to kind of go at a bird's eye view of everything that we've done and accomplished this year, at least the most important parts. We started out the year, we talked about the areas of physics, and we didn't cover all of these areas, obviously, this past year, but physics has various areas. We talked about the area of mechanics, which is the study of the motion of objects and objects in motion. Sometimes we call that area kinematics, but the textbook refers to it as the area of mechanics, and so mechanics has to deal with the motion of objects, okay, and objects in motion. This is the area that we spent most of our time in, and I want you to remember mechanics has to deal with the motion of objects. We have optics also, which deals with light and lenses and mirrors and things like that, and thermodynamics, which we didn't discuss too much, but that had to do with heat and how heat is exchanged. Waves, we talked somewhat of waves and vibrations this past week or so. And of course electromagnetism, which deals with electricity and magnetic forces. So these are just some. There's other areas of physics, but these are just some of the areas that we touched on. And so this was chapter 1 in your physics textbook. Chapter 1 also talked about some symbols, of which the most important symbol probably to remember is the symbol delta. This is the little triangle over here, and the triangle, or delta in Greek, means change or difference, the difference between two positions, the difference between two speeds or velocities. Anytime you have a difference or a change, you use this symbol delta. Very good example of the use of the symbol delta is our formula for calculating the average velocity. This formula you need to know. It's our average velocity formula, and it states that the average velocity, let's see, can I get out of that? Yes, good. The average velocity is the change in the position. So this here is change in position, okay, over the change in time. Average velocity is a rate. Anytime you see a change in time on the bottom, that indicates rate. And it's a change in position over change in time. This change in position is very important, and we called it displacement. So displacement was the term that we've been using to call our change in position, and it is delta x is our displacement. It was our final position of the object minus the initial position of the object. And why is this telling me this? Aren't I plugged in? Something's not right here. There we go. All right, so change in position. If we had an x-axis here, where this was our x-axis, let's say this is the 0 point or 0 position. If an object changed from some location here to some location here, where the x final was here, the x initial was here, so the change took place in this direction, we said it undergone a positive displacement. If, on the other hand, we had some position starting, let's say we had a position starting here, and it ended up to the left of where it started, then its change in position was in this direction to the left, and we said it was a negative displacement. We can also consider displacements positive and negative if something is vertical as well. So let's say we had an axis here where the 0 point, where the 0 was here, and some object, for example, was initially here at that position and then wound up at a point higher here. So our change in position went upward. That was a positive displacement. And likewise, if you had any kind of an initial point at any point along our vertical axis and it wound up at some lower position, the change in position was downward, so it's negative. So things like cats jumping up a tree would be an example of a positive displacement. A cat jumping down from a tree would be an example of a negative displacement. So we dealt with and talked about velocity and average velocity, and with average velocity then we talked about average acceleration. Average acceleration was defined as the change in the velocity over the change in time, and you need to know this equation as well. Average acceleration is the rate of change of velocity. Okay, the rate of change. Rate is important. It has to do anytime you're changing with relative to time, it indicates a rate. So if you have a delta V over a delta T, it's a rate change and it's changing velocity. That's what acceleration is. It's a change in velocity. We know that well, let's review. If our velocity was changing in this direction, in other words, this is V. V is in the positive direction, and our acceleration is also in that direction because acceleration and velocity are both vector quantities. They have magnitude and direction. So in this case, we'd have something that would be speeding up. If our velocity was positive and our acceleration was negative, so here velocity is in the plus direction, acceleration is in the minus direction, then we'd be slowing down. Slowing down. If our velocity is in the negative direction and our acceleration is in the negative direction, then we're speeding up again. Now you might think, well, how is that possible if it's going negative? Well, as long as your velocity and your acceleration are in the same direction, you're going to speed up. If they're in opposite directions, like here, then you're going to slow down. So if they're both positive, you're going to speed up. If they're both negative, you're going to speed up. If they're different, one is positive, one is negative, and it doesn't matter which one's the positive and which one's the negative, as long as they're different, you're going to slow down. So we talked about these kind of things. What you need to know for the final exam, and I think very important, is to keep in mind always our SI units that we've been using right through the whole year. For velocity, the SI unit is meters per second, and for acceleration, as I hope you all know by now, the SI unit is meters per second squared. That is, the acceleration is the change of velocity. It's how many meters per second are changing every second. That's where the square term comes in for acceleration. So in the next video, we're going to continue this review for the final. I'll have a clean board up for you. See you in the next video.